From Korea to Germany. From Alaska to Puerto Rico. All over the world, the men and women of your Army are on the alert to defend our nation, you, the American people, against aggression. This is the big picture.
Welcome to the big picture. I'm Captain Carl Zimmerman, here to tell you about your United States Army. And today the big picture shows you how the Signal Corps serves as the eyes and ears of your Army. You'll see how the Signal Corps, using highly specialized skills, devices, and techniques, provides the intricate communications and other facilities without which modern warfare would be impossible. Signal Corps photographers, overseas and elsewhere, have filmed many of the pictures you see on this program. And now, the eyes and ears of your Army, the Signal Corps.
This is war, modern technological war, a war of speed, movement, and quickly concentrated firepower. A fluid kind of war in which surprise is a major weapon. Today, more than ever before in our history, our Army must operate as a closely knit team. The action of each unit must be perfectly controlled. It must be timed and coordinated with the actions of all other units. Communications are vital for a rapid exchange of facts and the fast transmission of orders. In the United States Army, it is the Signal Corps that maintains these nerves of communication. The Signal Corps designs and develops equipment, installs it, and operates it. Wire and radio are integrated into a single fast-moving system to form the eyes and ears of command. In war, the role of the Signal Corps is vital. In modern war, it may be decisive. Swift new weapons require swift countermeasures, split-second warning devices, and high-speed communications. Signals must outspeed the fastest plane and outdistance the rocket. Distances are steadily shrinking. A direct attack from another continent is possible. Our military communications must be ready for such a challenge. This is the prime responsibility of the Signal Corps. Today it maintains a vast network of wire and radio channels that link Washington immediately with the Far East and Europe, with the most remote outposts on our far-flung defense perimeter. Modern global warfare requires a worldwide communication system of unprecedented size and complexity. Such a system has been set up by the Signal Corps. This system must provide instant communication with any part of the world and carry the traffic necessary for close coordination of widely dispersed forces. The key to this system is a global network to link Washington directly with each theater of operations. and carry instant warnings of impending enemy air attack to our continental defense centers. In each theater, we establish and maintain a network to link all elements, ground, air, and naval units, command, intelligence, and supply. The network has multiple circuits to provide alternate routes if any are destroyed by enemy action. Finally, in each theater, we have a combat network adapted to the conditions of modern mobile warfare. Communications in battle must be swift and flexible without giving vital information to the enemy. Let us take, for example, the first stages of an amphibious assault. These are the critical moments when precise timing counts most, when success may depend on a momentary advantage. Among the first troops on the fire-swept beachhead are Signal Corps units working with the Navy to establish vital ship-to-shore communication. Means must be flexible. The signal must go through. Today we are fighting in the mountains of Korea, where towering ridges separate our mobile frontline units and interrupt radio-telephone communication. Messages must get through. The Signal Corps is using planes and even homing pigeons as couriers. They use radio relays to hurdle the mountains. Here, a Signal Corps convoy makes the difficult climb to a mountaintop to install a station that will link a forward division command post with Corps headquarters. These stations provide a very high-frequency radio beam to carry radio telephone messages from point to point. Range is limited to the horizon. Since the beam is directed from station to station, there is maximum security against enemy interception. The equipment is portable and relatively easy to install. The relay mechanism permits messages to pass from telephones to the multiple-channel radio beam and back again. It also is adapted to the transmission of teletype, facsimile, and television. It is a major factor in increasing the speed and flexibility of our combat communications. The station is complete after the numerous tests and servicing adjustments are made. Today, as in the past, the Signal Corps keeps pace with the increasing speed and complexity of modern warfare. The Signal Corps has participated in the development of many of the electronic devices now used by our armed forces. It devised the controls for the television bomb. A television camera mounted in the nose of the bomb transmits a picture that shows the location of the target. Now, watch the operator steer the bomb by radio. There it is, a direct hit. Partly the work of Signal Corps engineers was the proximity fuse in aerial bombs and rockets. A major innovation in World War II, the proximity fuse greatly increased the lethal effect of our weapons. A delicate electronic device, it automatically explodes a projectile just before it reaches the target. Automatic automatically explodes a projectile just before it reaches the target. Assistance was given in the development of a technique to detonate mines by radio signal. The enemy can't explode the mines unless they know the combination of our frequencies. These combinations are set up through the use of a standard telephone dial. Motion pictures made by the Army Pictorial Service of the Signal Corps have helped to train every man in the Army, whatever his job. Training films are estimated to cut down the training time by at least 30%, and at the same time coordinates and unifies the Army's training programs. New tactics demand new techniques. An airborne invasion depends on a concentration of forces. The Signal Corps designed means to achieve this end, the Rebecca Eureka system. In advance of the landing, a paratrooper is dispatched to the designated drop zone. He carries a radio that establishes a directional beam. His part of the system is Eureka. Troop carriers follow with Rebecca interrogators to pick up Eureka's beacon. The Eureka beacon then guides them to the spot where the paratroops must drop. Movement of men and equipment to the airhead is precise, not a matter of guesswork. The Signal Corps was a pioneer in the field of radar, including radar for aircraft. This pilot, after dark, is looking for Boston. Signal Corps radar shows him the way. Here is what he sees as the sensitive echoes appear on his scope. The white spots are Boston and the surrounding cities. This gives him his bearing. With this device, bombers of the U.S. Air Force can now find and hit their targets at any time of day or night and in any weather. Signal Corps radar today is the electronic eye that enables our troops in the field to spot hidden enemy mortars and artillery from the arc of their shells in flight, to obtain necessary data for accurate counter-battery action. This same electronic eye today gives the signal to other electronic devices that automatically aim an anti-aircraft battery. The Signal Corps is the Army's official weather observer. Among the Signal Corps' weather instruments is an automatic weather station which can secure data even from points behind enemy lines. This delicate instrument is known as radio sonde. Radio sound automatically records and broadcasts at regular intervals changes in temperature, humidity, and atmospheric pressure, and gives it station identification. Signal Corps units were among the first to exploit the use of aircraft in warfare. From the Signal Corps' aeronautical section of World War I grew our present Air Force. Today, the Signal Corps again has an air section for photo reconnaissance. Through motion pictures and still photographs, we have seen the American soldier in the tense moment of actual combat. Think about the men who take these pictures. They have to be in the thick of the action. The Signal Corps combat photographers obtain a visual record of events at the front that is vital to our commanders in making decisions on strategy and tactics. These combat photographers help to fulfill the Signal Corps' mission as the eyes and ears of the Army. To enable the Signal Corps to fulfill this mission most effectively, scientists and engineers are pursuing a wide range of researches. In its own laboratories at Fort Monmouth, New Jersey, and under contract in civilian institutions, here, science is serving our national defense. Today, the main focus of this research is in the field of electronics, on the electron tube, which is the key to radio, radar, television, telephoto, and numerous other devices. The useful electromagnetic spectrum is being extended through microwave radar bands to wavelengths approaching infrared radiation. To develop new electron tubes for narrow beam communication and high definition radar. Signal Corps scientists are exploring the properties of the quartz crystal, the vital component that controls the frequency of most radio transmitters. Today, a synthetic substitute is being produced. Quartz crystals are a strategic item which the U.S. normally must import from abroad. A special heat processing method plays an important part in prolonging the life and efficiency of the crystals. Our scientists are studying the chemistry of batteries and developing new types to make portable radios lighter and smaller without loss of range. Battery capacity has been increased as much as 5 times, while weight has been cut in half. New power equipment is being designed, from compact 150-watt units to giants producing 15,000 watts for round-the-world radio transmitters. One of the problems of basic research is to discover how these radio waves travel. To probe the secrets of wave propagation, rockets carry Signal Corps apparatus 100 miles into the upper atmosphere. The Signal Corps made man's first contact with the moon. In a test to define the outer limit of radar, its scientists directed radar pulses upward through the ionosphere toward the surface of the moon and recorded the echoes that returned across a void of 200,000 miles of outer space. The Signal Corps is developing mobile television to flash battle scenes to our commanders and serve as the electric eye for our Army. Signal Corps technology is integrating radio and wire into a single fast-moving communication system. It is possible now for this man to communicate directly not only with this man and this man, but also with this man, so that all of them fight as a team. This solves only one problem. All equipment must be highly mobile to fit the tactics of modern warfare. It must be light and compact. Many new circuits no longer use conventional wiring. Instead, they are printed on strips, easily put into mass production. The Signal Corps has sharply reduced size and weight in a whole new series of portable radios for company and platoon. Field switchboards have been streamlined, but have greater capacity. Wire is lighter. During World War II, it took 2 men to lay wire with this cumbersome reel. The same footage now can be contained in a 26-pound package. It can be laid by 1 man. It can be laid by jeep or by plane over miles of rough country in a few minutes. Today's Signal Corps equipment is designed to withstand the roughest use and exposure in all kinds of weather. New specifications have to be met for new tactics of warfare. Size and weight are important in an airborne invasion. New techniques are devised to prevent breakage of fragile equipment. Here, a complete, very high-frequency radio station is deposited safely by parachute in the drop zone. Also airborne are the men of the radio operating crew who descend by parachute to assemble and put into action the equipment after the drop. 6 special containers swathed in heavy canvas padding hold the complete assembly, including 2 dipole antennas, power unit, frequency testing oscillator, and the radio receiving and transmitting apparatus. Today's Signal Corps equipment must be ready to function in the heat and humidity of a tropical jungle, or at temperatures far below zero in Arctic and subarctic regions. To make sure that signal equipment meets these rigid requirements, it is tested in every conceivable way before it leaves Signal Corps laboratories. First, it is subjected to the rigors of an artificially produced Arctic climate, then to blistering artificial heat. It is subjected to intense vibration and severe shock. It is exposed to drenching rain and enveloped in penetrating fog. In war, both men and equipment must face wide variations in weather. Weather observations and forecasts are vital to our Air Force and to our ground forces to correct artillery and anti-aircraft fire. The Signal Corps has developed a whole series of new weather devices for a wide range of tactical situations. Airborne radio sondes transmit data on atmospheric conditions up to a height of 140,000 feet, and radar tracks the radio sondes to chart wind speed and direction. A special type of radar has been devised to detect nearby storms and long-range detection systems that automatically plot the position and path of a storm thousands of miles away. Special devices measure cloud ceiling and thickness, providing data vital to air safety. Charts based on weather data gathered by these and other Signal Corps devices quickly circulate by facsimile transmission through the arteries of the Army's integrated communication system, giving information to our forces that is vital in all tactical situations. Today, Signal Corps communications are the link that enables ground and air forces to cooperate directly in battle. Here, a frontline observer pinned down by the enemy accurately guides a bomber to an enemy bunker. If another world war should come to this nation overnight, the first threat to our country and its cities may be a long-range attack by transocean bombers or missiles. Today, electronic devices can detect and warn of the intruder's approach from a perimeter of ships at sea and from a rim of scattered outposts. Today, planes can travel at sonic speeds and faster. Warning signals and target data must travel at once through our signal systems to automatic plotting devices at fire direction centers for split-second counteraction. Today, our battlefront is both in the field and in the laboratory. In both, the Signal Corps has a major role.
You've seen what the Signal Corps is doing to carry out its function as the eyes and ears of your Army. The Corps utilizes the latest advances in technology to make our Army the most modern in the world today. Next week on The Big Picture, we spotlight the Quartermaster Corps, enough and on time. This is Captain Carl Zimmerman, inviting you to be with us then.